Right, so in this video we said we are going to start looking at the coding, but not to look at the coding to understand every single line. That is not the point of this course. The codes will be there. I'll put the link to the GitHub where you can get these codes and you can run them by yourself line by line and try to understand them. But we are looking at the principles behind unsupervised learning. So here, this, of course, we're just importing the libraries that we are going to use for visualizations, for data preparation, and for the algorithms we are going to use. We're going to do logistic regression, random forest, XGB, and LightGB, right? Those are the ones that we are going to use. So the first part, of course, is to acquire the data. When you download it from Kaggle, you can put it on your local drive and then just import it. Right, you can just import it like I imported the credit card CSV. If you want, you can link it to Kaggle, but sometimes it might be, you don't want to link to to the internet. You don't want to depend on the internet connection, so you can just download it if you can. And here we are just exploring the data. This is the basics of what you usually do when you start a process of machine learning. You first explore your data, see what's going on here, look at the shape, look at the head. As I explained in the previous video, we have the time of the transaction, and we have these V columns that came from PCA all up to V28, and then we have the amount of the transaction and the class. The class is our target variable, right? Whether it was fraud or not, 1 or 0. So if you want, you can look at the description as well, and the columns. So yeah, this is important to look at the number of fraudulent transactions. We have 492 fraudulent transactions in our data set, as we expected, right? There are no missing values. It's a clean data set, although it has these V1s that we do not understand because they came from dimension reduction, but it's a clean data set. So yeah, if you want to count the number of distinct ones, you can count the number of distinct ones. In the time, it means maybe, because you see V1 we have 275,000 distinct counts, but here we have 124. So it means some transactions have like similar times, and here we have only two classes. That makes sense, 1 or 0. And the amounts, there are some transactions that have similar amounts. So 32,000 different amounts. It makes sense. Maybe you're just people are buying, let's say if it's bread we pretty much have the same in a month. We have the same amount, or like certain groceries and stuff like that, just like that we don't know what they were buying, but it does make sense that in a month in a certain area people will probably have transactions that have the same amounts, like 1,000 rand, 200 rand, 500 rand, whatever it's going to be. Yeah, so here we then generate the feature matrix and the label matrix, right? So our data X is going to be our features. We copy the data and then we drop this class variable, right? We drop this class column X is equal to 1. We drop the class column. Data Y, we just maintain. We create an array from this class. So I'm going through the code, but I'm not supposed to actually go through the line by line. I'm just telling you we are acquiring the data set here, and we have to scale the data set. So I'm just explaining this part, but in the upcoming videos, when you get down and dirty into the coding of logistic regression, just go through the coding and just go through the codes, and I'm sure you'll be able to understand. So we scale. We get the features that we have to scale, and then we scale them. We scale the features. So these are the numerical features. We just got the numerical features that we have to scale. We didn't scale the time. And we scaled everything else. This is a bit of description and exploration, right? And here we are looking at how imbalanced it is. Just look at this. Look at how imbalanced it is. It is incredible. 99 point something percent is 0, and we have 0.172%, which is fraud. So which is crazy imbalanced. So we're now doing the modeling. So yeah, in this video I just wanted to explain. We have a notebook. We have the notebook where we are getting the data set. We are getting the data. We imported our our packages that we'll be using, the metrics that we'll be using, and the algorithms themselves, and then we just imported the data. We didn't do much of feature engineering and stuff like that because probably it wasn't necessary in this case. It's difficult to do feature engineering, especially after doing PCA, because you do not know what these variables are, the v1s, v2s. If it was written here as distance, we could have created a variable called speed, because we would have done speed equal to distance over time, but we do not know what v1 is, so we can't do much feature engineering there. And that's the point with principal component analysis. There's some information regarding the original dataset columns that you will lose, because you are going to create these new components here that do not have any meaning when you compare them to the original dataset. Like maybe this could, in the original dataset we might have had age, gender, and stuff like that, but age is now all of them are mixed into v1, v2, v3. We'll see when you get to principal component analysis that these components actually house the original features in each one of them. So v1 has all the features in there, v2 has all the features in there, v3 has all the features in there. So we will see that when we get to PCA. So yeah, this was just acquiring the data, just looking at it to see if it's clean, but there's not much feature engineering we can do. In the next video, we are now going to get into the modeling part to see how we can start modeling and creating our let me do this and let me do it in this video, and so that in the next video we actually start logistic regression. So apologies for that. Let me just continue with the coding because we still have time, 6 minutes now. So you have looked at this, and then we start the preparation. We just do the normal train test split. We do 33% into our test size, and if you look at our train is going to be 190,000 and 93. Excuse me. Sorry for that. Sorry for burping. 93,000 is going to go into our test set. So just follow through the coding. Just follow through the coding, and we are going to use k-fold. We're going to use k-fold cross validation, and we are going to use five splits. If you do not understand what k-fold is, it is best. Supervised learning courses, they definitely go through k-fold cross validation. I'm not going to go through it right now because that is not the crux of this course. But if you do not understand it, I do have a course called supervised learning from first principles. And you can take that course. It explains all these principles. Here we are going to do stratified k-fold, which is our cross validation with 5 splits. In the next video, we are going to now get into logistic regression. We code our logistic regression model, train it, and look at the results. So stay tuned for that video.